Okay, I'm going to consider modulo arithmetic. And the basic definition of modulo arithmetic is quite easy. I'm going to introduce a concept called modulo, let's say modulo n, where n is any integer greater than 1. And I say that a equals b. Sometimes you say a is equal to b with kind of three lines. Modulo n if a minus b is a multiple of n. Multiple of n. So for example, if I'm going to consider modulo 2, here n equals 2, if I'm going to consider modulo 2, I might say that 11 equals 5 modulo 2, because 11 minus 5 is 6, which is even. It's a very rich idea. There's a very rich seam of mathematics here. So let's have a look at modulo 7. So 14 equals 0 modulo 7. 15 equals 1 modulo 7. 16 equals 2 modulo 7. See, I'm just adding 1 to each side here. And I can play games like this. What's 100? 100 equals 2 modulo 7. Because 100 equals 100 equals 7 times 14 plus 2, because it's 98 plus 2. So 100 equals 2 modulo 7. And if you're going to consider modulo 7, then normally any number, you only need to consider 0, 1, 2, 3, 4, 5 and 6. So in general, if you're considering modulo n, you only really need to consider numbers 0 less than or equal to x less than n. It's a very nice way of doing it. So normally that's kind of your what's the proper word for it? The reduced or minimum statement, I think it's called, least positive residue modulo n. So I'm going to stop there, and I'm going to cover lots and lots of examples in subsequent screencasts. Okay, stop there.